So welcome again this afternoon session, and before the business session we will have two talks, and I would like to introduce myself as the first talk, and then after that Daniel will do some demo and so on. So my talk today is about COMOD, a platform as a service for software-defined elastic system. Of course, it's not a product system. It's just a collection of several services that we have developed in Vietnam to support, elasticity engineering. Okay, so this is joint work with many people. Some of them are here, and funded by some AU project as well as some, some money from industry. So my talk today, I will have a short motivation to tell you why we are interested in supporting, software-defined elastic system and how we do this, and then I will explain to you some fundamental building block. Basically, I explain you the concept, and I show you some of our services with, of course, at the conceptual architecture level, because we have quite a lot of services and they are very complex. Anyway, it's done by some business students, so we always try to create complex software, and so on. Then after my talk, it's more like a concept. Daniel, he will show you some. I hope he can run a real demo with how to do some activity using our framework. Right? So I would like to recall the elasticity in computing. Some of you might not was not here last year. So you probably heard a lot of elasticity and Amazon and a lot of guys talking about elasticity and so on. And most of them saying elasticity is mean okay. Everyone agree that elasticity is mean we have to do as runtime, like scaling out. In and out, as runtime, but most of them say elasticity is mean, getting, more resource or release the resource, it means a virtual machine. So I would like to recall that elasticity has a different meaning here. So for us, first of all, elasticity could be demand elasticity. So it means that what you need, change over time at runtime. Think about yourself, right? You go to a restaurant, exactly, you need only one beer, but then you need a second and so on. It's the demand elasticity. Output elasticity is mean that, we have to think about that, okay, I can produce a product with different price, and quality. So I don't have to say, okay, my food is always like this, But I can say, okay, if you pay me a little bit more money, I add a little bit, sauces here and there, and you have different quality and so on. So think about it. And you also have input elasticity. It means that you should not assume that during your work or during, for example, like data analysis, you have a terabyte of data and it fit. Yeah, even very big and it fit. No, you should think about that during your analysis. Maybe, at the beginning you start with only 1 terabyte data from 100 sources. But during the analysis, suddenly you need to get some new data into the, the process. For example, you discover here some sensor data that you can take to account and something like this. So this is some sort of, you see input elasticity. It means something get into your system, is elasticity. Then of course, there will be elastic pricing and quality and so on. So it is not just the virtual machine, right? You can apply the principle of elasticity at different level of abstraction, and so on. So the motivation for our work is that if we say elasticity is a fundamental, in cloud computing, it means that by utilizing elasticity principle, we can achieve, a lot of things better. In terms of flexibility, in terms of pricing, resource utilization, and so on, right? Then we have to focus on how to engineer elasticity in your program, right? This is one of the fundamental properties of your cloud application. But if you look into, engineering elasticity in terms of, thinking about requirement analysis, execution, monitoring and testing and so on, more of the case now where you see, okay, there are some simple rules, right, to do elasticity control at the level resource. But what about programming? Are you able to specify certain elasticity property when you start to program your service, for example? As runtime, can you observe that if the application, for example, has some problem in terms of performance, in terms of cost, and so on. So the motivation does it, we need to deal with not only resource level elasticity, right? We need to deal with monitoring, we need to deal with testing, we need to work on elasticity across multi-clouds at the same time. And this is very challenging, right? So think about like this. So if you are saying now, forget about all other computing models, they are relevant, but you are interested in develop application in cloud, right? So you consider the cloud is your machine, right? Where you have a lot of objects, right? The object in your program would be some service where you go here and there, they are in Amazon in the US or somewhere, So think about it, right? Native service engineering in the cloud. So first you have to design and program, right? What we call software defined elastic service. And then you need to say, look, I click the button, and then it's automatically, deploy and configure my service, right? And then the other time you say, now my service is running, I want to see, how it works by monitoring and analysis. And then you have elasticity control, you say, okay, I need more data, okay, then get more data, you say, now the inputs increase or need more resource or something like this. So this is the basis, this is the basis phase. You phase during your software development in the cloud. And then you see there are different stakeholders, right? Different users they need. Okay, if you are service developer, say, I want to write my program in an easy way. I don't want to write, a Tosca topology with 1,000 nodes, very detailed. It's too complex for me. I want to say, I just click the button, then my code will automatically deploy cloud A, cloud B. If I don't want, I click another button, it moves from here and there, right? Think about cloud is just your computing environment, For example, I need to understand, the boundary of the elasticity. It means how far can I go with elasticity? Amazon say you can get virtual machine at whenever you want, but is it true? Can I get 200 virtual machine in 1 second? Can I get 200 virtual machine in, for example, in 1 minute? Or can I get 1,000 virtual machine? They say no, for example, because there are certain reasons, for example, right? So think about it. And then control, how do I, for example, increase the quality of the output, right? In data analytics, for example, if you add a new data source, right? You can predict much better. But adding the data source, it means that you need to take the data into your process, and taking the data into your process, it means very simple, right? Your program needs more memory, needs more CPU and so on. Then, the whole thing will be, impacted. So, there's a lot of questions. So, think like this. In an easy way, you should be able to say, okay, I'm able to develop my application with something complex like this. I have, for example, one topology, another topology, this topology, I have load balancer, I have event processing service. Here I have, data controller, data node, and so on. There are two topologies, but they can run 100 services inside each topology. And you say, I want to program and deploy such service. You see? And then you ask yourself, okay, I have this topology, but within this topology, for example, what kind of elasticity capability I can do, right? Not everything can be elastic in principle. So if you want to support this complex, application, you ask yourself, okay, maybe I'm yet able to do, for example, virtual machine, because this is the limitation of this system, right? But maybe I can easily to ask, a new database nodes in order to, for example, to improve, replication, performance, or whatever, something like this. So ask about what kind of elasticity capability here. And then you say, okay, but then what is the elasticity requirement, What do you want, You want that, okay, if the performance is going down, then getting 2 more virtual machines or something like this. And then you want to observe, elasticity measures. Okay? So this is what we want, right? When we develop and deploy and testing and running our application, right, in the cloud, and then we ask ourselves that, okay, I want tools framework to support me to do this, right? So what are the fundamental building blocks? Basically, the first thing for us, I think is very important, it's a little bit formal, conceptual, but it's important that we need to conceptualize and model elastic object. So my view is that we are living in the cloud, right? We program on the cloud. So what is the object in our program? Yeah, you write a Java program, then Java object is the object in your programming, right? You're always thinking about how to manipulate Java object, right? When you have a Java program, right? Destroy the object, create a new object, that bit lost in or whatever. It is similar. You are living in the cloud and then you think, I am programming the cloud application. So what is the object in your program? For us, the object is an elastic object which can be built on top of existing service and so on. So we need to conceptualize and have a very clear view what type of elastic object, right? And then you say, look, one important aspect is to control the elasticity. So what are elasticity primitive operations that you can do? I mean, Amazon might say, okay, I give you some primitive that you can create a new virtual machine, right? Cassandra, for example, say, I give you elasticity primitive so you can add a new database node, right? They don't care about VM. They say you can add a new database node in the cluster of database, for example. You can write a web services, then you say, my web services, the capability of, the elastic capability, I can increase the concurrent, for example, number of users I can serve at one time. It's up to you. But we need to define and capture, right? And then when you start to program, you need to think about, okay, what kind of recommendation and programming, elastic objects. So can you recommend me? I have a situation, I understand a little bit the requirement. Can you recommend me, should I run a virtual machine in Amazon or should I run a virtual machine in Flash? Because I have a situation that it don't happen all the time, but maybe there's certain time, in 1 minute I need 200 virtual machines. So maybe Amazon, I will to say, I can give you in 5 minutes you get 1,000 virtual machines. It doesn't mean that in 1 minute you need 200 virtual machines. So can you recommend Amazon or the other one, right? For example. And then how to program, right? And then runtime deployment, control, monitoring, testing. So it's an important building block. And for each building block, from the research perspective, we can create different kind of tool framework and write a lot of paper or whatever, right? So I want to show some of the principles that we are doing in Vienna. I'm not saying this is the best way, but I just say this is the approach we believe we should move, right? So first we say, look, every object that we are interested in our program, we will call it elastic service unit. So it basically, elastic is a property that each property can change over the time. Service is applied the principle of service. Oriented computing, it means that you must have a very precisely, clearly serving model, interface, pricing and so on. Unit is a principle from software engineering. You want to have only unit and easy to combine them together. Like component, in software product line, something like this. So that's the basic principle, right? And then you say, look, I have a function. Okay, everyone talking about function like doing something is a domain specific and so on. For example, like do some calculation, do some data analytics and so on. You have a very clear serving model. For example, this is pay-per-view, what's the price, what's the ownership, related to the service, related to the data, provisioning, dependency, For example, I have a unit, and this unit depends on which unit. Say, I have a Docker, it's a unit, right? A Docker is depend on a virtual machine, for example. I have a web container, right? Docker as a unit. This Docker rely on Docker, and Docker rely on VM. This is one situation. Maybe you say, I have a Docker, just rely on VM, not rely on Docker. Why? Because I have different constraints, right? Security, for example. Okay? Then you have elastic capability, as I mentioned before. It means what kind of capability, what kind of primitive operation that you can have. right? So this is model. Somebody would like to buy on this model and write UML diagram to allow people to model this and that. You're welcome to do. We are not the UML guys, so we are working a little bit in the system level. But I mean, this is the principle. Yeah? We can use this, develop a UML to model this one and generate the code and so on. So next, when you have this model, you need to model and capture elasticity primitive. Here I show you some just example. If you look into different cloud infrastructure and so on, you see there are virtual machines where you can add memory, add core, remove memory. You actually can change the region and then you can increase the memory, the size, you can even change the license and so on. Not every cloud provider provide all of them, right? But if you work on multi-cloud environment, you suddenly see somebody allow you to get a virtual machine, remove the virtual machine, change the software without changing the license fee for the software, right? Somebody say if you change, for example, the software with the new version, you have to pay the money and something like that. So there's a different primitive. You need to capture this, right? And now thinking about programming, yeah, I give you an example. Assume that you have a very complex application like this. By the way, this application also available in GitHub. So we provide as a sample. It's a real application. So you have, for example, a load balancer. You have a client send something. For example, here a lot of sensors send it to the load balancer and then event processing. And from the event processing, you store the data into data nodes, right? So you want to program this, for example. Then you ask yourself, okay, load balancer, what about the cost? Per hour or per gigabyte. Event processing, what it is? So that you have very small VM, for event processing, or so that you have very big one. A lot of questions, right? So even when you start to design a service in the cloud, you ask yourself, right? Even that there's a repository with a lot of services there. You ask yourself which one are suitable for you already, right? So it's very complex. So then, runtime. The runtime configuration, the problem is, we yesterday and today we probably heard, okay, Jet, Tosca, something like this. They are the tool allow you to do some deployment. But I think the important thing that you have to think that when we have a complex service, we never work on a single software stack. It means it's not that when I want to deploy my service, then I will take my software, like Java and everything, and put into virtual machine and deploy the whole virtual machine. It's different. Sometimes you want to deploy the whole virtual machine. Sometimes you just want to deploy a new Docker on a virtual machine which already running. Sometimes you already have a Docker running, then you just want to deploy, for example, the Tomcat. So you see, the problem here is multiple software stack and as runtime, right? So it's a different with, say, easy thing, just download everything from repository back into an image and deploy. This is okay only when you work in a single stack, or it's only at the beginning. When you deal with elasticity and runtime, you need to deal with multiple stack here, right? And then control, you need to specify, elasticity control in a very high level view rather than very low level. It's difficult to understand, right? And then monitoring, right? We need to utilize low level monitoring. I mean, you guys know a lot of monitoring, and some of them suddenly very popular in cloud computing, like Gambia. I mean, like 15 years ago, even when we worked on grid computing, it's a very unstable system. Gambia already there, and now very popular in grid computing because they allow you to, to get a plugin and have the monitoring data and send around. But it's not the key point. The key point is when you have a cloud application, how do you get the monitoring data associated with your application and able to correlate information from application to the system, right? This is the key point. And if you look into monitoring data, more people talking about CPU, but okay, in the environment where you say, I have only one virtual machine, one of my process running, maybe measuring the CPU loss is okay, reflect your application, but it's not true, right? So we need to correlate the information, different layer. And this is the key point of cloud computing. And we need to analyze this. It's not easy. So we need to develop elasticity monitoring and analysis, right? And forget about low-level monitoring like CPU memory, which you see every cloud system. And then testing. So you say, now I'm living in the cloud, I'm programming elastic object, how do you test it? Yeah? You cannot just open your laptop and run and test in your laptop. It doesn't work because it doesn't reflect, the cloud behaviors, right? And you probably know, even you run everything in the cloud, is many times, the cloud is very unstable in terms of performance. You even run the same program, the same log, and everything in the same cloud, the performance is very different because it's a virtualized environment. It's a very different, right? So I want to show you some technique, the Vienna way, the way how we do. I mean, this is the concept. We can take it and implement your way. And here we have some concrete services, some concrete software framework that our people in Vienna, they do implement to show, some fantastic concept that we just show here, right? So one work that what we have is recently, it will be appear in SummerSOC conference this September. That is the question of how do we quantify elasticity, right? So you have, for example, here a lot of providers, a lot of services. You say, I have a lot of services, and so on. Then at the end you want to have Tosca or CME that you can automatically deploy. In between, you have to do a lot of hard work, right? Requirement analysis, recommend programming, and so on. So what a very simple and starting point we ask ourselves, hey, if I have two services and I put them together, how can we quantify the elasticity relationship between them, right? For example, even at the design time. So we come up with some quantified function and configuration recommendation with the hope that we can accelerate the development. So for example, if you tell you want to use Amazon A, service A with rack space service B, maybe the combination would give you certain elasticity property like this, for example. So from that perspective, we have, we model elasticity capability. I'm not going into the detail of everything here because if you like it, without a lot of paper available in website, without a lot of software, sample, everything, you can play a little bit, maybe a couple of hours to learn a little bit, and then you run it and you see. And then you also have to model elasticity dependency, right? You know their service cost, resource quality. Then here your service, it's very complex. It's not just one single service, right? You have topology and a lot of units. Then you have some sort of requirement like constraint time, and you have some kind of, we say, okay, strategy, I would like to, for example, build elastic on the typical one. And then some runtime property, like for example, usually you say, I will have a virtual machine, but usually I use this virtual machine only 2 hours. It's a very different when you say, I want a virtual machine, but I want to use the virtual machine for 1 week. Think about, for example, simulation, right? Let's put if you remind in the morning like scientific workflow, right? When you have a scientific workflow, you have a task. What activity do something? That activity, for example, can run just 10 minutes finish. So it's very good if you run one virtual machine and say, I want to use the virtual machine in 2 hours, but actually in 2 hours, one virtual machine, but you run 1,000 tasks because every task is just finished, in 10 minutes. So you actually deploy the virtual machine only one time, but you continue to use it. This is the batch job model, for example. Another model will say, this is a very heavy, right? Heavy service, also in the workflow, but you say, look, this job, for example, usually take 1 week, so I don't want to keep the same virtual machine, but I create a virtual machine, right? And I run only one job for 2 weeks, and then I kill the whole virtual machine. This requirement is very different, right? So based on this one, we come up with a couple of equations, grid letter to define something, right? And basically, if you use this kind of grid letter and add a little bit some domain knowledge, they can recommend you, okay, instead to use Amazon service A with Amazon service B, you should use rack space service A with flash and service B, something like this. Yeah, it's better you get the concept. So then, this is the design time, and you like it, and you take this, you put into the system and it generates Tosca like from farm work, and then you can deploy. Yeah, in the paper we show how it works, for example. Another one does is you say, oh, come on, I want to design a service, but I have to use open Tosca, define all kind of node type, right? All kind of relationship, it's so complex. So say, I am a developer, let's do it very simple, right? I can do it the way different like domain-specific language. So why don't we capture different kind of node type, different kind of relationship into certain library, and then just keep the user, the developer, simple domain-specific language, right? And then he just write the domain-specific language, and as his application rather than create complex topology and so on. This is exactly one of our guys. He looked into the way to abstract, very complex type and so on. They present simple domain-specific language, right? To write this. And when you click this one, then of course the interpreter will generate Tosca everything for you. If you want Tosca, if you want hit, generate hit, for example. If you want the other one, we can generate the other one and deploy and run, right? Now I want to show you another tool as I mentioned, right? Configuration and deployment is not started thinking like take the software, pack everything, and then deploy the whole virtual machine. But you have to think like this. When you think about configuration capability, you think about, okay, maybe something related to elasticity operation, maybe something related to optimization, primitive, they all call some primitive. But then configuration can apply for what? For virtual machine, for container, for application, and especially they are at runtime. So you cannot use chat or whatever, in a simple way, because it means that it just automatically, deploy the whole virtual machine, at the starting point. So you need to also provide certain lightweight components sitting in the virtual machine at runtime and do the deployment. I mean, this concept is not new, right? Like your router at home automatically download the software update from somewhere and do it, right? But think that engineering is very challenging, right? Because we run in multi-cloud, multi-stack, engineering this is very difficult. But this is the principle. We have to do multi-level stack here. And then specify elasticity should be simple like this. You just say, okay, I have this kind of response time, I have a strategy like this, and if something wrong, follow my strategy. And let the algorithm, the system to decide how to execute. Because when you say the performance going down, get a new virtual machine. If you work at the level of primitive, right? And then you say, if the monitoring data of performance like this, then go API, blah, 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 right? It's very detailed, precisely, depending on the cloud. It's really a nightmare, So let the engine do it and specify something like it. So this one we published last year. And now this kind of principle we apply for multi-clouds. It means at the same time you have your application running cloud A and cloud B. The control can control some part of cloud A and cloud B at the same time. It's not single cloud anywhere. And if you think about engineering, low level is a nightmare because cloud A can have completely API, cloud B has completely API. And then if you have to write by yourself, this is a nightmare, right? So I give you an example, like we have OpenStack, then we have Flashen. You probably know Flashen. We used to call Flashen in the Amazon of Europe because this is the only one, I would say, ERS, infrastructure as a service in Europe. And now they will like it because we have problem with NSA. So suddenly, they are very good for us. So we don't run, our application outside Europe. But simple way like this. If you want, you can just develop different plugins, right? And add into our system, right? And then think about it. This is some sort of primitive you capture and you put into some configuration. So whenever there is a new primitive, you get modified configuration. And the principle is the engine has different plugins to work with different clouds. And then they're able to capture primitives so that at runtime they know exactly which primitive they should do in order to increase the performance or reduce the cost or something like this. It's important for software engineering for elasticity. So if you go inside the controller, is why complex? Because the problem of multiple stack. So you have application, your application running a virtual machine, it related to the network, and you have virtual cluster, right? You have a process level, operating system level, process level, virtual cluster level, and so on. So we need to manage it. So what we are doing, that we build a very complex dependency graph that we basically give, all the instance, units, the units instance in our application into a dependency graph, and we monitor them over the time, so that at runtime we can generate, the right API. We can call the right API to manipulate, the cloud system, by calling the elasticity primitive. You can change the virtual machine, or you can change the network in principle, or you can, for example, redeploy something, right, as runtime. So it's important that it's so important that you see elasticity control has some sort of intelligence, high-level intelligence, but if you call a lot of low-level, like primitive operation, and even call the deployer, right? Because if you need something, then you call the deployer to deploy something at runtime, right? Because you are elasticity controller, you make decision, right? The deployer is not really intelligent. He can do a lot of deployment if you tell him where, So it's important. You see, for engineering, this kind of thing, we need to connect things together, right? So the interesting does is, at the beginning, when you write your application, you can specify the elasticity policy like this, ABC. But at runtime, you can actually replace the policy with a new policy if you want. Yeah. At the moment, we do not change the application structure, right? But we can change the policy, the elasticity primitive. It's different because if you change the application structure, you need to do some checkpoint and recovery. It's much more complicated, stuff. And then you ask yourself about, okay, I have elastic application, how do I do the monitoring and so on? Here I just visualize, a simple concept, right? What we call elasticity space and elasticity pathway. The interesting that is, I want to explain to you that if you show me all kind of matrix, it doesn't mean elastic matrix. Why should I call elastic property if it's just all kind of typical matrix? So we put ourselves elasticity matrix only when the application or the service in the elasticity behaviors, right? So then, when you say this service in the elasticity behavior, you can think about a couple of metrics. You think that, okay, this is metric that establishes my view on the elasticity. So based on that kind of metric, you can take all the low-level metric, whatever, and build up what we call elasticity space. Yeah. So you think about elasticity space here. We show it very simple, and a tree, a triangle, but principle, the elasticity space is a manifold. Mathematically, is a manifold. It's like this. Because when you say now, I have a new elastic metric, then you change. So you can see like then. What you really want to do in terms of elasticity control is to make sure your application or whatever within the boundary, right? No matter it's more like this or that, you always in the boundary. Because when you are outside the boundary, you violate the elasticity principle from your perspective. So we have the concept of elasticity pathway, as a way to determine, for example, where will you go? It can be done from prediction perspective, it can be done in terms of extrapolation perspective, and so on, depends. So you actually can have a lot of different techniques. At the moment, we have a foundation, so we can build an elasticity space, we have certain functions to do the pathway, but you can write a lot. I mean, this is really a lot of research question, that you can exploit. And then, now things are very complex. So another question for you that is, I already told you about, okay, we have deployment, we have control, we have topology. So if you look into the way how it works, right? Say, I have information, like this is my service, and I deploy, right? When I deploy, my service running here and there, and I have another dependency graph, and then I apply control process. My service, dependency graph move from here to here, and so on and so on. So, how do you learn the relationship between them? It means the relationship between the dependency graph, the deployment process, the control process. Because if you make a wrong deployment process, all kind of control is useless. Because it is impossible. When you move, you make a wrong deployment into cloud infrastructure where they have very limited elasticity capability. You do the monitoring, you are able to detect, but what can you do? You're probably not able to do anything, right? So it is very good to understand what are the relationships. So we are working on what we call a lattice state machine, but we have not come up with the results yet because it's too complex here. So it means that when you have a state A, as a elasticity state A, how can you move to another elasticity state B? By on what? By on deployment process, by on control process. Okay, if by on control process, what does it mean? By on the cost control, by on the quality control. Okay, if quality is by on what? Network, computation, or data. This is too complex for us at the moment, but this is the way we want to see. So then I show you fundamental thing. Now we put everything together, we call common. Yeah, so we have 4 or 5 different services. We put together, we call common. So here the principle. The guy who do some programming, he can deploy, and then he can do analysis, and then he can test, and and then he can do some instrumentation and so on. This should be done with a very nice graphical user interface. At the moment, we don't have, right? Okay, our business student doesn't want to write graphical user interface anyway. But this is principle. So if you can imagine a nice graphical user interface for you to do this, and then underneath this all kind of service I already mentioned to you, right? A service for managing ecosystem and recommend, a service for deployment, a service for control, and a service for monitoring and testing. And then here you have multi-cloud, so you can deploy, control, monitoring. You also can generate test case in the cloud and then use the test case to test the service here, right? For example. So this is the principle. So we explain a little bit in the Bible and IC2E this year. Okay, a lot of concept, but for you it's very easy because most of the things I mentioned here already have in GitHub with open source. So you see, Keller is the guy who supports quantification of elasticity. It means you can play around and take the algorithm and then say, okay, what's the relationship? RCO is the service that allows you to specify elasticity, the primitive, and do the control. Mela is the monitoring. SASA is the deployment. AutoClass is the testing. And in code mode, we currently integrate Keller, RCO, Mela, SASA, so they are working a little bit nicely. Not everything already done, but they work together. What's important, if you like it, you go here. There's a lot of prototype, but stick into the name, because if you download the other prototype, they are different, right? But you remember the name, you go here, you see it, and then you download it. They also have a lot of use guide. I mean, not a lot in terms of production, but in terms of research, it's quite a lot because they explain to you how to do the configuration, how to test, and so on. And at the moment, we test, for example, in Flashion, in Amazon, OpenStack. We also test in Dubai, the biggest data center in the Middle East, or Okeanos in Greece, and so on. So actually, a lot of courses run in multi-cloud. Of course, there are also a lot of bugs. So you can find the bug in the system. We also have an integration, continuous integration server. So you actually can see when the guy commit the new source code. It shows you automatically some information there. So here I go a little bit the architecture of, for example, Keller. You see here we have like service model, right?
And then we have a way to store the data. We use, for example, Neo4j, for example, to store all the data. Then we have some algorithm to do the quantification. Then the output could be Tosca. At the moment, the output is Tosca, and actually you can use front Lehman group over Tosca to visualize the result, right? This is, for example, Keller, Sasa. There are no publication yet, but the source code have been for a long time. And in the morning, you see Stefan, he do IoT deployment, for example. Basri also using Sasa, you know. So we apply Sasa not only in cloud data center, but also IoT gateway and so on. Here, Archivo has a lot of documents about how it works. You know, it integrates to Sasa, Mela, and so on. And you can deploy it unlimited with flashing with OpenStack, with Okeanos and Fujitsu cloud computing, based on Microsoft technology and so on. So it's work reasonable. And Mela, right? With functionality, like with Mela you can integrate to Gambia, or then you can write your own monitoring code, to send the information to Mela, but Mela will focus on elasticity analysis. So in principle, we work from the programming to the monitoring to the testing, but we are particularly focused on elastic perspective. So that asks me, okay, write the real business of your service, because it's not our focus, right? So you have to use our tool to write the core functionality of your units, but you can use our tool to add the flavor of elasticity, and then combine them together to do some sort of, let's say, native cloud engineering, And then Daniel will show some feature I mentioned here, with live demo and so on. I don't know, as much as you can. So for the conclusion, I think it's very important if we keep in mind that we are living in the cloud. Okay, I'm not saying that we are only living in the cloud, right? But put ourselves that we are living in the cloud, so the cloud is my machine. So I think a very simple view, the cloud is my machine. I have to program by using the instruction, right, from the cloud. And what is the instruction from the cloud? For me, the instruction from the cloud is being used to manipulate a lattice object. And what is the lattice object? For me, is have a clear function, clear, lattice primitive, and so on. And the rest is how we glue things together. And it has to be done in an interwoven way. You cannot think about sitting in your laptop and try the code and then test a little bit here and then click the button deploy. Yeah? You have to think about that. You work on the cloud. So it's important that in the future we need to focus more on the programming language for the cloud, right? So think like it. Java is the programming language work on top of Java instruction, right? Defined by some JVM is the virtual machine. Now assume that the cloud is JVM. What is the Java for the cloud? Yeah, this is an open question. I don't know. Yeah, so we want to focus more on that and test things, right? Because we work a lot on control monitoring. Now is the time to do testing. It's a little bit strange, right? We should do the testing at the beginning. Okay, so I'm done with my talk and I'm open for questions. Thank you. No question? If you don't want to make a question, it's also okay. You can ask Stefan. Ask Daniel in his talk, because he will run something. Okay, here I'll talk a little bit more concept. So, but no question? Pablo, what did you want to ask?
It's a concept. I'm sorry, well, I'm going to it's very interesting that the BSL for elastic objects. Do you see it as in this future work, do you see it as a combination of current paradigm or as a new paradigm of the current way of programming?
I don't know, but I would like to do a new paradigm, because I would like to have a DSL based on our concept of elastic object. And I would say from a programming perspective, we need to work on, the concept of elastic object. Yeah. Okay, so no question then. Daniel, you can run a demo.